In a DNS system, there is not just one central server that happens to contain the database of all potential mappings of web addresses to their respective host IP addresses. The DNS server is actually a hierarchy. The DNS hierarchy comprises the root level, the top level domains, the second level domain, the subdomain, and the host. Let's understand them using an example next. At the top level of that hierarchy are the DNS root servers managed by a variety of organizations such as VeriSign, University of Southern California, NASA AMES Research Center, US Department of Defense, ICANN, and so on. Below them on the hierarchy are what are called top-level domains, of which there are over 1,000. These include generic top-level domains such as .com, .net, .org, .edu, along with country code top-level domains such as .au, .ru, .cn, and .ae. For each of these, there are second-level domains. Under .com, there would be a Udacity second-level domain. Other examples include Stanford, Wikipedia, etc. Then below the second-level domains are the subdomains. You probably only regularly navigate to one of Udacity's subdomains, such as www or .eu. But there are a number of others, for instance, .br for Brazil and blog for our blog. Finally, each of these subdomains can be mapped to one or more hosts or IP addresses. Now that you're familiar with the DNS hierarchy, let's look at how your computer would try to resolve the name of a website, for instance, www.udacity.com. For the purpose of this example, we're going to pretend that you've never visited this site before, because if you have, the A record will actually be cached locally, and your computer will resolve the FQDN into an IP address almost immediately. So for us to see the resolution of an FQDN across the DNS hierarchy, let's pretend that no device has ever visited www.udacity.com before, and therefore, it cannot be found in any of your caches. So you type in www.udacity.com and hit enter in your browser. Your computer must find the correct IP address of Udacity web servers. Your browser will ask your operating system, or OS, where it should send the request. And the OS has a set of resolvers configured, which usually point to an authoritative DNS. Since we are going on the assumption that the authoritative DNS has never seen the site before, it's then going to ask the root servers, hey, who handles .com? The root servers will respond with .com is handled by foo. The authoritative DNS server continues talking to the foo top-level domain now. It will ask, hey foo, who is authoritative for www.udacity.com? And foo will respond, udacity.com is handled by bar. Now the authoritative DNS server asks the bar second-level domain specifically where it can find the www record. Bar then responds with a set of A records. The authoritative DNS returns these to your browser, which uses one of them to retrieve the contents of the web page. As you can see, FQDN resolution is a recursive process. It usually happens right to left. First you resolve the .com top-level domain, then the Udacity second-level domain, and finally the www subdomain. In reality though, Udacity is a popular website and it would be stored in many of the server's caches. In fact, since you visited it before, it would be cached locally on your machine. And even if it wasn't, your ISP's authoritative DNS would have a cache. To resolve www.udacity.com, you wouldn't need to go through all of these steps. But they are good to know, as this is what happens for a new query.